Now we are discussing about finite and infinite sets. So consider this example. A is a set X such that X belongs to N. X is even number. Okay, and consider one another example. B is equal to X such that X belongs to N. X is even number and X less than or equal to 10. Okay, now write the roster form for A. So we have to write natural numbers which are even numbers. That means 2, 4, 6, 8 and so on we will get. Okay, and write roster form for this. B is equal to, here we have to write natural numbers which are even numbers and less than or equal to 10. That means we have to write 2, 4, 6, 8 and 10 also we have to consider because equal to is here. So up to this. Now just tell me how many number of elements are there in set A? Can we say the finite number? No, because it is unlimited elements are there in set A. And consider B. How many elements are there in B? So if you count 1, 2, 3, 4, 5, there are 5 elements in B. So when, if it is possible to express the number of elements of a set with a whole number, that may be 0, 1, 2, 3, 4 like that. Here it is the number of elements is equal to 5. Number of elements in B is equal to B is equal to 5. If we say that the number of elements with a whole number, that is called a finite set. This is finite set. If we can't say that with a fixed number, fixed whole number, then that is called infinite set. Okay, so that means if we count the elements with a whole number, if we express the number of elements in a set with whole number, that is called finite set. If number of elements are unlimited, so it goes on, then that is called infinite set. Consider the example X, set X such that X belongs to N and X minus 1, X minus 2 is equal to 0. Here we have to take such natural number which satisfies this condition. So first we have to solve this equation, and from that natural numbers we have to take and write in this set. So let's see, if X minus 1 into X minus 2 is equal to 0. If A into B is equal to 0, then we can solve this by A is equal to 0 or B is equal to 0. Okay, by taking A is equal to 0, we have to solve, and B is equal to 0, we have to solve. That means X minus 1 is equal to 0, then X is equal to 1. If X minus 2 is equal to 0, then we get X is equal to 2. Okay, now so we get the solutions as 1 and 2. Both are natural numbers. So the resultant set is 1 comma 2. Here we can say that 1, 2 fixed number of elements are there. Therefore this is finite set. Now consider the other example X such that X belongs to N and X is prime number. That means we have to write natural numbers which are prime in this set. We know that the prime number starts from 2. So 2, 3, 5, 7, 11, 13 like this. These are not end. Okay, these are endless. The prime numbers are endless. Therefore, we can't say the fixed number of elements. So this is infinite set. This is infinite set. Okay. Now we will see the cardinal number of a finite set. So cardinal number is nothing but the number of elements in a finite set is called cardinal number. For example, if you consider the set A is equal to 1, 2, 3. Here the number of elements in A is equal to 3. Therefore, cardinal number is equal to 3. Okay, number of elements in A is equal to 3. So cardinal number is equal to C. Then we can write this as n of a is equal to 3. We read like this, n of a. Okay, n of a is equal to 3. Okay, consider the other example. C is equal to x such that x is alphabet in the word India. Then the roster form for C is, we have to write I, N, D, A. So then number of elements are 1, 2, 3, 4. Then n of C is equal to 4 we have to write. Just see this problem. If A is equal to 1, 2, 3, 4, 5 and B is equal to 2, 4, 6, 8, then find the relation between n of A, n of B, n of A intersection B and n of A union B. So first we have to write, if A is equal to 1, 2, 3, 4, 5, then what is n of A value? N of A is equal to 5. And if B is equal to 2, 4, 6, 8, then we get n of B is equal to how much? 1, 2, 3, 4. We get 4. And now we have to find A union B. Already we know that A union B is nothing but 1, 2, 3, 4, 5 union B. B means 2, 4, 6, 8. We have to write. Then it gives, first we have to write these elements 1, 2, 3, 4, 5. After that 2 already is here, 4, yes, 6 and 8. So we have to write 6 and 8. Now n of A union B is equal to, from this we get n of A union B is equal to how much? 1, 2, 3, 4, 5, 6, 7 elements. So you have to write 7. Now come to A intersection B. A intersection B is equal to, we have to write A value, that is 1, 2, 3, 4, 5 intersection B value, that is 2, 4, 6, 8. Now we have to write the intersection. So 2, 2 both are common. 4, 4 both are common. We get only 2 elements. That means n of A intersection B is equal to 2. Now we have to observe the relation between these two. So to observe this, just we follow Venn diagram. Just observe this Venn diagram. If we want to count the number of elements in A union B, that means we have to count the elements in this area and common area and this area. It's enough. So the number of elements in these three areas gives us n of A union B. If we do n of A, what will happen? We will count the number of elements in this portion and this portion. Okay, that is, this is A only portion and this is common portion. So here we are counting A only portion number of elements and common portion elements. Okay, in case of n of B, if you observe, we are counting these elements and common elements. That means this is B only. Then we are counting B only elements plus common elements. Okay, so if you do n of A plus n of B, that means here we get A only elements plus common elements and n of B means B only elements plus common elements. If you observe that n of A union B means A only, common portion, B only. That means A only, common portion. Up to here we will get n of A union B. And once again the common portion is extra. Common portion is nothing but n of A intersection B. That means n of A, if you observe that from this, n of A plus n of B, by adding these two we get n of A union B plus n of A intersection B. Okay, so if we shift this, then we get the relation like this. We got the relation n of A plus n of B is equal to n of A union B plus n of A intersection B. So to get n of A union B, move this to this side. Then n of A plus n of B minus n of A intersection B is equal to n of A union B. This is the relation. Now we will check this relation with previous example problem. Now check the relation in this example. So first n of A plus n of B minus n of A intersection B we are considering. N of A means it is 5 plus n of B means it is 4 minus n of A intersection B means it is 2. So 5 plus 4 is 9. 9 minus 2 we get 7. If you observe that n of A union B is exactly 7, that is equal to n of A union B. Okay. Therefore, keep in mind the relation very important, n of A plus n of B minus n of A intersection B is equal to n of A union B. Now, if A and B are disjoint sets, A and B are disjoint, then what will happen? Just see, disjoint sets. Already we know that if A and B are disjoint sets, then A intersection B is equal to 5. Then number of elements in this set, n of A intersection B. So 5 means we have to open the bracket and just close the bracket. Then number of elements are no. Therefore, we get only 0. Number of elements is equal to 0. Then if you observe this relation, n of A plus n of B. N of A intersection B is 0. So minus 0 is equal to n of A union B. That means when A and B are disjoint sets, we get the relation n of A plus n of B is equal to n of A union B. This is important. If A and B are disjoint set, we get the relation like this. Okay. Dear students, we discussed all the sets topics and solve the worksheet problems, okay, which are given below. Thank you.